Hey there! Today we're going to talk about function transformations with a focus on vertical shifts. That means we're going to be moving functions up and down today. So let's say we have a little sun at the point 2, 4. So that means that the x value is 2 and the y value is 4. If we translated the sun 7 units down, what would the new coordinates be? Just using context clue, what do you think the word translated means? Translate means to slide, or move, or shift. So if we're going to translate this sun 7 units down, it would look something like this. So I'm just going to count from the sun, 1, 2, 3, 4, 5, 6, 7, and my new sun would be here and not there anymore. That was 7 units down. So what would the new coordinates be of this point? So the x value is the same. It's still 2. But the y value is different. If this is 0, we just count -1, -2, -3. So 2, -3. So when we do a shift or a translation up or down, you'll notice that the x value is not going to change. So that is a helpful hint for today. Let's talk about parent functions. You can kind of figure out what this means from the word parent. Parent just means kind of like original, like the OF, original function. Think of your parents. They're kind of like the original versions of you before changes happened. So these are the functions that are just very basic. They kind of center around the origin. If you look at their equations, just like this one, it's based at the origin, and it's just, it's kind of hard to see, but it's just x squared. There's no extra numbers. It's not like x squared minus 3 or x plus 2 squared. It's just very basic. Same thing with this line here. Y equals x, centered at the origin. So these are very just basic functions. So we're going to take these parent functions and kind of move them around the graphs, and you'll see that the equations might change. There might be a +2 at the end or a -3, something like that. So let's look at this parent function. Y, or f of x equals x squared. Remember, y and f of x are the same thing. So let's look at what happened. We had our vertex, which is the bottom point, right on the origin, which is at 0, 0. And then the vertex moved. How many units did it move, and in what direction? Well, we went from the origin 2 units up, 1, 2. So if you look at the equation, we have the original here, x squared, but if we go 2 units up, we have a +2. That's the same thing as saying 2 units up. Now a unit is just like a little box here. So it went 2 boxes up, so we can call those units. When we're talking about function transformations, we want to give a number of units that we move and a direction, like up, down, left, right, something like that. Today we're just going to talk about up and down. All right, let's look at another vertical shift. Vertical means either up or down. Okay, so we have our function here. I know the colors might be kind of weird. So we have our vertex, x squared plus 3. It's plus 3 because it's 3 units above the origin. And let's say we took this vertex and we moved it down. Okay, so how many units did we move down? Just 2. So this was our original, and this is our new one. If we look at the equation, this is a little more complicated than just x squared, but our original equation was x squared plus 3. And now we have that original x squared plus 3, so we're going to bring that down, x squared plus 3. But because we went 2 units down, we're going to include a -2 at the end. So this is one way that you can show in an equation what direction you moved in. You just put a -2 at the end. Now another option you have is to actually simplify your equation by combining like terms. If I combine these two constants, +3 and -2, by adding them together, what would I get? So 3 minus 2 is just 1, so I can rewrite this as, I'm going to keep my original, which is x squared, and my new number here, which is +1. And that would get you the function here. So really, we went from a +3 to a +1 to get from 3 to 1, you went down 2. So there's a few ways to think about these and a few ways to actually write the equations. You could totally leave this unsimplified and leave it as x squared +3 minus 2. That's fine, but it's a little more sophisticated to include the +1 at the end, and that's probably what you would see on a exam. Okay, let's do another one. Above the functions, f of x equals x squared, which is in pink right here. That's your x squared. I can tell because it's at the origin. And g of x are graphed. Determine an equation for g of x. Okay, so here's what we want to do. I'm going to start by setting up an equation for g of x. Every equation has to have an equal sign. So g of x equals. Now, I don't really know much about g of x, but I know a lot about f of x. So I am going to use the information I know about f of x. Now, there's two ways you can write this equation. You can use the name of the function that they tell you about, or you can use the actual variable. So let me show this to you both ways at the same time. So I'll make some room. G of x equals, and g of x equals, and one I'm just going to have the name of the function, and the other one I'll have the x squared. Okay. Let's figure out what happened here. So looking at my functions, I see I went from the origin, 1, 2, 3, 4, to right there. How did my vertex move? How many units in what direction? It looked like I went 4 units down. So how can I show that I went 4 units down in my two equations? It's going to be the exact same way. 4 units down is the same thing as -4. So whether you write this with the function name or the function itself, as long as you have the -4 at the end, that's telling whoever's reading this that we went 4 units down, we shifted. Let's look at a multiple choice. So there's a general way to show a function shift. Just +a means that we're going to be adding some kind of constant at the end. So you can technically add a negative number. So this plus is kind of like a plus or minus, but we just show it as a plus usually. Anyways, to the right, there's a graph of the function f of x. Which graph below shows the graph of f of x -2? So make sure you're looking at the vertexes, okay? Which of these choices represents f of x with a -2 at the end? So -2 means that we went down 2 units, and that would leave us here, and choice 3 has the vertex 2 units down from the origin. Let's do some practice. Let's see if we can identify the shift and how many units that we translated. Okay, so x + 4 is shifted. To answer these questions properly on an exam or on anything, you want to include the number of units that it shifted, so 4 units. And a +4 would be up. So 4 units up. Let's do the next one. X minus 5 is shifted. That would be 5 units down. Let's do a couple more. We're going to use the absolute value of x. Same concept. So absolute value of x minus 10 is shifted. That would be 10 units down. And absolute value of x plus 3 is shifted. 3 units up. So minus is down, plus is up, and that is for vertical shifts, the up or the down. Let's do a multiple choice question. This is very similar to a Regents question. I'll read it out for you. Read along with me. Omar graphed the function f of x equals x squared minus 3. He then graphed the function g of x equals x squared plus 2 on the same coordinate plane. Coordinate plane is just this. The vertex of g of x is, and then if you look at the choices, we have some options. Is it 3 units below, 4 units above, 5 units above? So you might be at a point where you can do this in your head, but I'm going to use my coordinate plane to help me out. So normally, x squared is based at the origin, but I'm going to graph x squared minus 3. And you could use a graphing calculator for this really easily. So x squared minus 3 would put me 3 units below the origin. So that would be right there. I'm going to label that as f of x. That's just the vertex. I could graph the entire function. It's just like a sketch. It's not really super accurate. All right, let's graph the next one. This would be x squared plus 2. So x squared would be here, but x squared plus 2 is going to be 2 units above the origin. So if I was to graph that one, just a sketch, I'm trying to figure out how can we describe the vertex of g of x compared to f of x. So I'm starting at f of x and I'm going to g of x. Which one of these choices describes that shift? So if we count up, we have 1, 2, 3, 4, 5. So 5 units up. The choice that's the most similar to that would be 5 units above. So I'll go with that. There's another way that you can do this. You could think about it as a number line. So as to draw a quick number line like that, let's say there's my 0, and I have -1, -2, -3, and 1 and 2. So I really went from -3 to +2. So -3 to +2, if I was to count, 1, 2, 3, 4, 5 units. And it's positive, so it would be up. So you're really just figuring out how do you get from -3 to +2. Let's try another one. This one's very similar. Justin graphed the function f of x equals -3x plus 1 squared plus 2. He then graphed the function g of x equals -3x minus 1 squared minus 5 on the same coordinate plane. The vertex of g of x is... So this is a way more complicated looking function. My advice would be to figure out what's actually changing in between these two functions. So what's the only part of the function that's different? That's going to be the end, the constant at the end. We changed from a +2 to a -5. The -3 is the same, so we don't care about that. The -1 is the same, so we don't care about that. So I can really get rid of all of that stuff because it's not going to help me. I'm just trying to figure out how do you get from +2 to -5. So I'm going to help you out here by making up a vertex. I know it's going to start +2 for f of x. And for g of x, -5, 1, 2, 3, 4, 5. I'm starting at the green, which is f of x, and going towards the orange, g of x. Which choice describes that shift? To go from f of x to g of x, we go down 1, 2, 3, 4, 5, 6, 7. So 7 units down, and it looks like choice 1 describes that best. Again, you can also maybe do this in your head. How do you get from +2 to -5? Well, there's 7 units in between, and it's decreasing, it's going down, so that would be below. Let's do another one. This one looks more complicated than it has to be. Danette graphed the parabola f of x equals x squared minus 4x plus 3, which has a vertex at 2, -1. Find the coordinates of the vertex of the parabola defined by the graph g of x equals f of x minus 3. There's a lot of information that you don't need here, and on the regions, they actually said use of the graph is not even necessary. But let's use it to help ourselves out. So I honestly don't care about the equation of parabola. I'm going to just focus on the vertex and plot my point at 2, -1. Right there. That's my vertex of f of x. And then they tell you that f of x is going to be moved. So regular f of x would just be f of x without that, but now if I put a -3, what does that mean? What direction and how many units are we going to move? So -3 means 3 units down. So if I'm going to take this vertex and move it 3 units down, what would the new set of coordinates be? Here's how you do this. I'm going to go down 1, 2, 3, plot my new vertex, so g of x, and then I'm just going to put my x and y values into this set of parentheses. So my x value would be, look at that, it's still 2. Those don't change. My y value would be, I just have to count -1, -2, -3, -4 for my y. So that would be my new set of coordinates. You didn't have to know the parabola. You didn't even have to graph. You really could have just seen like, oh, I'm going to take this point and move it down 3 units. So that means I'm going to keep 2 the same and then do -1 minus 3, and I get -4. So you can do it in your head. You can use the graph, whatever works for you. So that's it for today. Just let me know what you thought of this lesson.